Hey everyone, welcome back to our channel. Today we are diving into one of the most interesting topic in machine learning, which is clustering algorithm. Clustering helps us to organize and understand data by grouping similar items together. Think of it like sorting a pile of toys into groups based on their type. In machine learning, clustering is used for things like customer segment, image recognition, and even spotting anomalies in data. In this video, we are focusing on two popular clustering algorithms, which is K-means and DBSCAN. We will learn what they are, how they work, and where they are used in real world. Before we jump in, don't forget to hit the like button, share this video, and subscribe to the channel if you haven't already. So let's get started. First, K-means clustering. K-means is one of the easiest and most used clustering algorithm. Here how it is work. It divides your data into K groups or clusters. How many groups you ask? Value decided could be 3, 5 or any number depending on your data. The algorithm works by choosing random points to start with, called centroids. Then it checks which group the data point belongs to. Based on how close it to centroid, it keeps adjusting the group until everything is sorted neatly. Let's break down the steps of K-means to make it super clear. Pick initial points. The algorithm chooses K random points as a starting centroid. Think of this like a starting position for the groups. Assigning points. Every data point gets assigned to closest centroid. If a centroid is closer to one center than another, it joins that group. Moves centroids. Once the points are assigned, the centroids moves to the average position of the points in their groups. Fourth is repeat. The algorithm repeats the process until the centroid stops moving. At this point, your cluster are ready. K-means has its strengths and weaknesses. Advantages are it is easy to understand and works well with large dataset. It is fast, so it won't take long time to give your results. Disadvantages are you have to pick the number of clusters beforehand, which is not always easy. Okay, it is sensitive to starting point. So if the initial centroids are not chosen well, the result might be off. Next up is DBSCAN clustering. So let's talk about DBSCAN. Unlike K-means, which divides data into groups based on distance from centroid, DBSCAN uses density to find cluster. It looks for area where data points are packed together tightly and consider area with fewer points or noise or outliers. This is helpful when you don't know how many clusters you want or your data doesn't fit neatly into circular shape. Here's how DBSCAN work. Core point. DBSCAN look for a core point. These are data points that have a lot of neighbor nearby. Expand the cluster. Once it finds a core point, it starts expanding the cluster by linking it to the near core point. Border point. Points that are close to core point but don't have enough neighbors themselves are called border point. They belong to cluster but are not core points. Noise points. Any points that don't fit into cluster are called noise and they are treated as outliers. What's great about DBSCAN, it does not need to specify the number of cluster. It figures that out based on density of the data. Just like K-means, DBSCAN has its pros and cons. It can find cluster of different shape, not just circular ones. It is great at handling outliers or noise in your data. You don't need to decide the number of clusters beforehand. DBSCAN has many disadvantages like DBSCAN can tricky to use because it is sensitive to the settings like the distance between the points and the number of neighbors needed to form a cluster. It does not work well when your data has cluster of a different density. So how do K-mean and DBSCAN compare? K-mean divide the data into group based on distance from centroid, while DBSCAN group data based on density. K-mean work best when clusters are round and evenly spaced. DBSCAN can handle cluster of any shape. K-mean require you to decide the number of cluster upfront, but DBs can figure it out as it goes. DBSCAN is better at handling noise data and finding outlier, whereas K-means struggles with that. Both K-mean and DBSCAN have a real-world uses. Customer segment. Business can use clustering to group customer based on how they shop or who they are. For example, K-means can help divide customer into marketing groups. Image analysis. Clustering helps us groups to part of an image, like pixels that are the same color or texture. Anomaly detections, which are DBSCAN is perfect for spotting outliers, things that don't fit in, like fraud in financial data. Location clustering. Clustering can also be used to group places that are close together, like restaurant in a city. To wrap up, clustering algorithms are key in machine learning to group similar data points together. K-mean is simple, fast, and work best with evenly spaced or shaped data or clusters, while DBSCAN is flexible in finding clusters of all shapes and handles noise data very well. Both have their strengths, so choose one that fits your data best. Thank you for watching. If you found this video helpful, please like it, share it with others. Don't forget to subscribe the channel. Your support helped me creating this video. So see you next time. Bye bye. Thank you so much.